Hey everyone, and welcome. Today, we are going to talk about something that's, well, it's pretty much everywhere, powering our entire world. I'm talking about the humble, but seriously powerful, electric motor.
So to kick things off, let me ask you a question. Think about your fridge, your car, maybe it's an EV, and, that fan you've got running. What is the one thing they all have in common?
Yep, you got it. It's an electric motor. It sounds complicated, but at its heart, an electric motor does one really simple, almost magical thing. It takes electrical energy, from a wall socket or a battery, and turns it into actual physical movement.
Okay, but how? How does a jolt of electricity actually make something spin around? It feels like magic, right? Well, it's not. But the science behind it is just as cool.
So, the secret ingredient here has a big, fancy name: electromagnetic induction. I know, it sounds a little intimidating, but trust me, the basic idea is actually pretty easy to wrap your head around.
So let's break this down step by step. First, you run an electric current through a wire. Simple enough. Now here's the cool part. That current creates a magnetic field all around the wire. Then you bring another magnet close by. What happens? They interact. They'll either push apart or pull together. If you can control that push and pull in a circular way, you create something called torque, which is really just a spinning force. And boom, that's your motion.
Okay, so not all motors are the same. You can basically split them into two big families. And what separates them is what kind of electrical food they eat. Let's get into it. We're talking about AC and DC.
First up, you've got your DC motors. DC stands for direct current. The easiest way to think about this is batteries, or the power brick for your laptop. It's a nice, steady, one-way flow of juice. Then you've got the other team, AC motors. AC means alternating current. This is the electricity that comes from the outlets in your wall. The key difference is that this current is constantly flipping its direction, back and forth really fast.
So, when you boil it all down, the main difference is how they get their power. Think of DC as a one-way street. The electricity only flows in one direction. AC, on the other hand, is like a two-way street where the traffic is constantly changing direction.
And it gets even deeper. Within those two big AC and DC families, you've got all these different subtypes. We're not going to get lost in the weeds today, but just know that each one is designed for a specific job. A super efficient brushless DC motor is perfect for a drone, while a big, tough AC motor is what you'd find running machinery in a factory. It's all about picking the right tool for the job.
All right, so we've got the basic principle down, and we know about the two main types. But what's actually inside a motor? What are the key parts that make it all work? Let's take a look under the hood.
So the first and most obvious part is the rotor. The name kind of gives it away, right? This is the bit that actually rotates, the part that spins. It's the star of the show.
But the rotor can't do it alone. It needs a partner, and that's the stator. Stator sounds like stationary, and that's exactly what it is. It's the fixed outer part of the motor, and it creates the magnetic field that makes the rotor spin. This is where that push and pull force we talked about really comes to life.
So how do you make a magnetic field just from electricity? That's where the windings come in. These are just coils and coils of wire. When you send electricity through them, they turn into electromagnets. This is the real engine room, turning electricity into magnetism.
Now, if you have something spinning really fast, you're going to get a lot of friction. That's a problem. The solution? Bearings. These are what support the rotor and let it spin super smoothly without grinding itself to a halt. They're the unsung heroes that keep everything running.
And finally, in a lot of DC motors, you'll find this really clever little part called the commutator. Think of it like a smart switch. Its whole job is to flip the direction of the electricity at just the right second to make sure the rotor keeps spinning in the same direction. It's what keeps the motion going smoothly.
Okay, so we've looked at all the pieces, the rotor, the stator, the windings, but these aren't just parts in a textbook diagram. When you put them all together, you get a device that has completely shaped our world. So why does all this matter? Well, without this simple interaction between electricity and magnetism, our modern lives would look very different.
I mean, just think about it. Your household appliances, from your blender to your washing machine, the massive equipment in factories that builds everything we use, the electric cars that are changing how we get around, even the tiny, precise motors and robots, they are literally everywhere, the hidden workhorses of our society.
When you strip it all away, it comes back to this one simple, powerful idea. You put electricity in one end, and you get motion out the other. It's an elegant concept that has completely changed the game for humanity.
So that leaves us with one final question to think about.
These motors have already revolutionized everything. They power our homes, our jobs, our transportation. The question isn't what they do now, but what comes next. What new, incredible things will the electric motor make possible for us tomorrow?